We're live, Verge.
Hey everyone, thank you so much for coming back and joining us for our second day of AP Calculus Live, AB. Today we're going to do 7.2, verifying solutions for differential equations. But before we get started, we're going to do a few introductions and just kind of talk about some stuff that we also talked about yesterday. So my name is Verge Cornelius, and I teach at Lafayette High School in Oxford, Mississippi. I've been teaching for about 30 years. This is my first time ever teaching virtually. And I do want to mention one thing about that word, Lafayette. It is only pronounced in that way right here in Lafayette County, Mississippi. Everywhere else, it's Lafayette, which is the French way to say it, of course. Go ahead, Mark.
Hi, I'm Mark Corelli, and I'm at Ryan High School in Denton, Texas. And Verge and I have been friends for about 12 or 13 years now, and I just found out that's pronounced Lafayette this week. Or it's not pronounced Lafayette. I'm sorry, Lafayette.
Yeah. It took me like 6 months to get it good. So La.
Fay.
Okay. Right. Anyway, so just so folks know, especially folks who are joining us for the first time today, what's going to happen between yesterday, March 25th, and May 1st, which is going to be our last live session, is that we are going to instruct on differential equations, which is going to take us about 6 days. We did topic 7.1 from the CED yesterday, and we're going to do 7.2 today. Then in Unit 8, we are going to do topics 8.1, 8.2, 8.3, and 8.4. If you want to look at your CED, those are all of the units, but not volumes. And we are doing those because they track very nicely to previous units that are being tested. As you know, many of you know already, AP Calculus this year, we're not testing anything directly in Unit 8 at all, but many of those first 4 units have nice tiebacks.
And for those of you, the CED comment was more for the teachers, but for the students that don't speak all of our acronyms and abbreviations, CED is the course and exam description, and you can find that on AP Central.
That's an excellent point, Mark, because, you know, different textbooks that teachers use might have these all in different chapters. So these aren't necessarily going with your particular textbook's chapters. That's exactly right. And then once we do those topics in Unit 8, we are going to review all of the tested topics in 2020, in addition to weaving in test-taking strategies for this exam, which is a unique exam because it's going to be online this year. We don't know anything really other than that much else, and we're going to know a lot April 3rd, so we're going to know what you know when you know it. So for today's lesson, we had our introduction, and this happened to me yesterday. I have a little list of things that I want to do, but you know, we just introduced ourselves, but we also want to welcome everybody who's watching us, and in particular, of course, the students. We had over 55,000 views yesterday. So we know that those aren't just the teachers watching. We know that it's the students who are watching. So go, great job. Anyway, we are welcoming, of course, the teachers and our colleagues who are watching us and supporting us and giving us feedback, of course, fixing our mistakes for us and all that other kind of good stuff. In a little bit, we're going to see our warm-up for today and go over that warm-up. That's going to take about 5 minutes. Then we'll get into our lesson, verifying solutions for differential equations. That's going to be about 15 minutes. And it's going to go like yesterday, where I'll work a few and then I'll give you one to work on. And then we'll talk about that one and proceed in that way. Towards the end, we'll talk about all the resources that are available below every single video. There's that little description, and you can click on that link, and those resources will be posted after the lesson, and we'll talk about that towards the end. So without further ado, we'll get started. So here's our warm-up for today, and it goes back to yesterday's lesson, which was to model situations with differential equations. Our first one here, number 3, should look really familiar to you. It's the one that we made a mistake on yesterday. Well, I should say I made a mistake on it yesterday.
Oh no, I followed your mistake. We
and
were
then,
in. We're a good team.
Who's the fool? The one that follows, or whatever? You know the quote better than I do, Mark.
The fool or the fool who follows him.
The fool or the fool that follows him, right? So here's our warm up. In number 3, it says the rate of change of J with respect to t is inversely proportional to the square of j. So we'd like you to write that as a differential equation. And then if you looked at your download yesterday, you saw number 22, which was not yet, I didn't go over it yesterday, but maybe you've already gone over it for yourself. The rate of change of the intensity of a response R with respect to the intensity of a stimulus S is inversely proportional to the intensity of the stimulus. This differential equation is known as Fechner's law. So those are our 2 warm-up questions. I'm going to give you about 30 more seconds to write your differential equations. And if you're just joining us for the first time today, I reminded everyone yesterday that hopefully you're treating this like a class. You actually have a notebook paper out and you have pen, pencil, calculator perhaps right by your side so that you really can interact with the live session. If you're watching it afterwards, of course, you can pause as needed, and that way you can kind of pace it yourself. So, okay, I'm going to go ahead and switch to my document camera. Let's see if I can do this. I did it.
And just so you guys can know how impressive this is, we just did the feed, went from Texas to Mississippi. That's pretty cool.
That is pretty cool. Okay, this is my low tech right here. This is my reminder to myself that today is Thursday. We're in our second AB Live. We have 26 to go after this one. Okay. All right, number 3. So this is what I had written yesterday, and unfortunately, none of my students were watching me make the mistake, or they would have all shouted at me. You know, folks like DC or AH, they would have shouted at me to say, you know, Miss Cornelius, you have a mistake on the board, or they're a little more polite than that. I think. Okay, so where was the mistake here, Mark?
It says the square of J.
The square of J. That's right. So how about if I do this? Would that be the square of J?
If you raise it to the 4th.
Oh boy, that would be so cool.
Yeah, that's
now, listen, I'm using these pens because they're erasable.
Because mistakes happen in math.
And I know that some people have another kind of pen that's my favorite pen, and it is here in the wings in case I need it, just so you know. We got my favorite pens here. Okay, so it should be dj dt is equal to k divided by j squared. That would be the correct differential equation. And then for 22, it says the rate of change of the intensity of a response R with respect to the intensity of a stimulus S. So there's my differential expression right there. So I'm going to write dr ds, if I can, maybe get this going. There's my S is, so equals, inversely proportional to the intensity of the stimulus. So the stimulus is the S variable, inversely proportional. So I could say this is equal to K times 1 divided by, or 1 over S. I could also write that as just K over S if I wanted to. When we were preparing this, we were loving looking up these different laws, and Fechner's law is actually, go ahead, Mark, you looked it up.
It was psychophysics. It's related to the intensity, the perceived intensity, that patients that had better vision to see the stimulus perceived a stronger stimulus.
Wow, that's cool. Okay, so that's our warm up. And we're going to go ahead and get into our lesson, which is, as you know, and here comes some more of my low tech stuff. which is verifying solutions for differential equations. And as I was thinking about this lesson, I was thinking to myself, what does it really mean to verify solutions? What does the word verify even mean? And the word verify means truth. You know, figure out if it's right or not, figure out if it's correct. That's what that word verify means. And I thought to myself, hey, we do that in Algebra 1. You know, I can determine which of these, if any, is or are solutions to this quadratic equation. This is one of the first things I might do in my Algebra 1 class without even knowing how to solve a quadratic. I can just check and see if any of these are solutions. How would I do that? How would I check without knowing quadratic formula or factoring? How would I do it? I'd plug them in. So I'd say for 6, I'd say like 6 squared minus 6 minus 6, and I'd check to see if that equaled 0. Does it? 36 minus 12 equals 0? Nope, it doesn't equal 0. So that's not a solution. How about for -2? -2 squared minus -2, and then minus 6. So let's see here, 4, and then plus 2, and then minus 6. We're trying to see if this equals 0. That's what it says. Does it work? Yes, it does. So that one is a solution. For -3, let's see and check if that works. -3 squared minus -3, and then minus 6 equals 0. So 9 plus 3 minus 6, Mark, make sure to shout at me if I'm wrong. This is looking like 15 minus 6, which is not 0. So that one didn't work.
The only thing I might do different if I was doing these, when I do determines like this, I put a question mark over the equal sign.
I love that. You know what? I was totally thinking that when I was doing that. So we were kind of checking to see if that was 0.
Yeah, that's just kind of avoiding that false equality, which becomes a big deal later on when we start talking about exam tips.
That's so true, isn't it? Love that. Okay, and then for 3, some of you guys might have already worked it at home to see if that worked. 3 squared. Let's see if I can model what Mark just said. 3 squared and minus 3 minus 6. Does this equal, question mark, 0? Does this equal 0? And let's see, I have 9 minus 3 minus 6. Yes, indeed, it does equal 0. So that's my other solution. And I'm not going to get too much into quadratic equations and how many solutions they may or may not have, but my point being is that what we're about to do in calculus, we've already done before in other kinds of math courses. So now each day when we do our lesson, I want to definitely credit where we got our materials from. And today we actually got our materials from AP Classroom. And this is important for teachers to remember. All students have accounts in AP Classroom, but they can only do the practice if you unlock it for them. And so these came out of this 7.2 in AP Classroom, verifying solutions for differential equations. And we're going to work some of them right now. I'm sorry that this is fuzzing in and out. Go ahead,
if you happen to be a student at Ryan High School, one of the 2 quizzes that you got assigned today is going to match this pretty closely.
Good.
See if they're watching.
Okay, so this is the 0 example. The function, and by the way, all of these, I know I said it before, but all of these are going to be in that Dropbox at the end of the live, and we are not going to do all of the examples live, but you can go back yourself and do the examples that we haven't done, and all of the answers are there as well, so you can check yourself. All right, let's see what this one says. The function y equals e to the 3x minus 5x plus 7 is a solution to which of the following differential equations? So this function here is a solution to which of these differential equations? So as I look at these, I say to myself, well, I don't see a dy dx. Oh, but y prime really is a dy dx. And then this is the second derivative here. So indeed, these are differential equations. They just look a little bit different from the kind that we were writing yesterday, different kind of notation. So one thing that I might do to see which one is a solution is I would go ahead and I would take this equation right here and I would differentiate it. So I'm going to rewrite it for myself. I've got y equals e to the 3x minus 5x plus 7. And y prime is equal to derivative of e to the 3x. I'm going to go ahead and need some chain rule here. It's going to be e to the 3x and then times the derivative of the 3x, which is 3. And then minus the derivative of 5x is 5. And then this derivative of plus 7 is 0. So this ends up being 3 e to the 3x minus 5. And I'm going to need the second derivative as well. So I'm going to take the derivative of the derivative. The derivative of 3e to the 3x is going to be 3e to the 3x, and then times the derivative of that exponent, which is going to be 3. And then minus the derivative of 5 is going to be 0. So that's just going to equal 9e to the 3x. So I've got my first derivative, I've got my second derivative, and now I can just go ahead and substitute them into the equation and see if I get a true statement or a false statement. So I'm so sorry about this fuzzing in and out. I had somebody actually message me that if I press this AFL, it would help, and I'm pressing it, and it's not helping, but it's okay. All right, so in A, I have, again, I like to write stuff down again. I have y double prime minus 3y prime minus 15 equals 0. I'm going to substitute in. So my y double prime is going to be 3 e. Here goes that eraser again. I'm looking at the wrong spot. It's going to be 9 e to the 3x. And then minus, and then 3y prime would be 3 times these two terms here, 3 e to the 3x minus 5. And then close parentheses, and then minus 15 equals 0. Distribute this negative 3 to both of these terms. I'm going to bring down my 9 e to the 3x, then minus 9 e to the 3x, and then plus 15 minus 15. Does this equal 0? That's what we're checking. We're checking, does it equal 0? I'm putting that little question mark, like, question mark. Like Mark said, to do the question mark. Okay, anyway.
You are the first person in 48 years to ever point that out to me.
No, I know I'm not. Okay, anyway, do these actually add to 0? And in fact, they do. So I do get a true statement here. And so my answer is actually the first one I checked, which is pretty nice. Now, realistically, would this be a question on the AP exam this year, 2020? No, because we know, okay, maybe this is new information for you, but there are going to be no multiple choice questions on any AP exam, not just on calculus. So this, you might say, well, this was a waste of my time. Actually not. This is excellent calculus right here. And this is how you would verify and check to see whether or not these could be a solution to the differential equation.
Yeah, this question could easily be a free response if you take B through D away and just say, verify this is a solution to this differential equation. And then you do have to show the steps that Verge showed. And it's funny, it's just, I'm going to steal yours for a second. The layout of our work is just, I even made the mistake at the start of the plugin.
Oh, wow.
And I had started that before you did it. So I thought that was pretty funny.
I'm impressed with your multiple colors. I think you missed your calling as an engineer.
Yeah, unfortunately for the AP test, you're allowed a pencil and a pen, but with Take It Home today, I guess the colors would, or this year, the colors might be allowed. So
that's right.
Go ahead and grab that back. But yeah.
Oh, I got to grab it back. Yeah. Okay. So start share. Yeah. Okay. So I do want to say also, before we move to the second example, is that if, and I'm talking to teachers right now, when I originally planned this lesson, I just took screenshots with College Board's permission off of AP Central for this lesson, and Mark retyped everything for me. Thank you so much, Mark.
You just want everyone to know the typos are mine.
Well, no, I already told you to fix them. Well, you're right. We could find additional ones. Okay, here comes my second one, and it's number 1, actually, my second one. And there were reasons for that, but we changed our plan. So anyway, so this one says if dy dx is equal to y secant squared x and y equals 5 when x equals 0, then y equals, and then we've got all these choices here. So this is a little bit different, and a couple of different strategies to do. This right here is a point. So 0, 5 needs to be on the y equals right here. So me personally, that would be the first thing that I would check into each of these expressions, substitute in 0 for x and see if I get an output of 5, because I might be able to rule out some choices. Then after that, I'm going to have to go ahead and take the derivatives, perhaps, of my remaining ones, and then see which one seems to fit structurally with this differential equation. I might also add that, you know, the more you work with this, the more you look at stuff and you say, it can't be that one, you know, but when you're first starting out, you got to test them all, you know, and make sure that you're covering all your bases. All right, so let's go ahead and substitute in 0 for x. And these are my y equals expressions. So when I substitute 0 in for x here, I end up with e to the tangent of 0
Did we lose Verge? Is that what happened? All right, well, hey, let me take over. Okay, it's just, hey, so we're having an unintended switch. That's fine. I was yelling at my family that they were using up my Wi-Fi. All right, I do not have the document. Verge was working on problem 1 when we got into this. So let me go ahead and sum that up while we wait for her to get back into the meeting. We've got dy dx is equal to y secant squared x. And we had that 0.05. And I'm not sure exactly when you guys lost Verge, but I know we had seen there was an e to the tangent x plus 5 was my b. And so I think she was on the way of eliminating this one right away, because we have this e to the 0 is 1 and 1 plus 5 is 6 when we evaluate this at x equals 0. And so that one's going to have to get thrown out. All right. Some other things to look for is we see evidence of y showing up again here. So when I look at option D was a tangent x plus 5, and dy dx is going to be secant squared x plus 0. And of course, we've got the secant squared x, but I want to see evidence of my original equation there. So now D is gone. Let's see if I can I'm going to go ahead and swap my share. I don't know, does the default go to the slide, or are you guys getting to see me live and large? That's kind of frightening. Okay. So here's number 1. And I have somebody in my chat box. If she will confirm that you can see the PDF on screen right now, that'd be great. Okay, so we've eliminated B and we've eliminated D. When I look at E, I'm just going to do this visually right here. If you can see my hand, we've got the derivative of tangent is secant squared, which again gets us that part we want. But we're going to have this sum of 5e to the x in our derivative. So since this is a product, E's gone. So I know I'm playing with C and A now. These are the only two I'm playing with. The derivative of e to the tangent x, and I'm going to go back. And we're going to do a new share. All right. And I apologize for this. We weren't planning on going live with me until next week. But this is the fun of doing it live. Anyone who thinks we've taped these things ahead of time, you know that's not true. All right.
Hey, everybody.
Hey, Verge.
I don't know what happened.
I think you lost your internet. So I have eliminated, I believe, C, D, and E. We're playing with. No, I take that back. We eliminated B by the point, and we eliminated D and E. So if you want to pick it, take it back. I was just about to investigate B and C.
Okay, thank you. Okay, so,
Oh, Claire, can you, I'm sorry. Unnamed person behind the curtain, you probably need to make her a co-host.
Yep. I need to become the co-host again. This is exciting. Cheapers.
It's done. Go ahead, Verge. Steal it away.
Okay, thank you.
Products of the 20th century playing in the 21st century.
Okay. All right. So I'm back. Thank you for your patience. I was having, did you take the derivatives of these two and that's why you eliminated them? Okay, perfect.
And we were looking for that evidence of the initial function y in our answers.
Okay,
which is a good reason to start looking for an exponential right off the bat, was where I was about to go. So
right. Structurally, that's exactly right. So
here comes the baton.
Here comes, I'm going to check C. I know it works in C, but I'm going to go ahead and check C in terms of taking the derivative of it. So if I have y is equal to 5 e to the tangent x, this is my option in C, then y prime or dy dx is equal to 5, that's just a coefficient, e to the tangent x, but then times the derivative of that exponent, the derivative of tangent x would be secant squared x. So right here, what I can see is that 5 e to the tangent x is actually y. So my dy dx is in fact y times secant squared x. This is y, and then times secant squared x. So my answer there has to be C. A is not going to work because when you take the derivative of it, just for emphasis here, dy dx, this is on A, checking it, is going to end up being e to the tangent x, and then times secant squared x, derivative of tangent x there, and the exponent is going to be secant squared x. E to the tangent x is not y. It's e to the tangent x plus 4 is y, and so these are not equivalent in terms of the substitution that we would do. So this one's pretty close, but it's not correct. All right. We're going to do number 3 next. And again, you guys don't have this in front of you if you're watching live, if you're still with us, that is. But so I'll read it and you can jot down the pertinent information. It says a curve has slope 2x plus 3 at each point on xy on the curve. Which of the following is an equation for this curve if it passes through the point 1, 2? So here again, we're looking at, well, out of all these choices, maybe I can rule some of them out because maybe 1, 2 is not on that graph, the point 1, 2. And just by looking by inspection, I can look here and say 5 times 1 is 5, 5 minus 3 is 2. So that one definitely seems to work. What about the next one? 1 squared plus 1, I'm getting 2. So the points on that one. What about this one? 1 squared plus 3 times 1, 4. So that's not going to work because my point is definitely 1, 4 instead of 1, 2. And then on this one here, 1 squared is 1 plus 3 times 1 is 3. So this is going to be 4. And then minus 2 ends up being 2. So 1, 2 is this graph. of this equation. And then here, 2 times 1 squared is 2, and then plus 3 times 1 is 3. So 2 plus 3 is 5, minus 3 is 2. So 1 comma 2 is on that one as well. So we only ruled out one choice based on that point 1 comma 2. Let's see about the calculus though. Right here it says a curve has slope 2x plus 3. The slope is 2x plus 3. That means that dy dx is 2x plus 3.
At every point xy, yeah.
At every point xy on the curve. So which of these remaining choices has a dy dx equal to 2x plus 3 on every point on the curve? Well, certainly not A. What's dy dx for A?
Rhymes with 5.
Yeah, so here dy dx is 5. What about dy dx? So that's not right. What about for B? What's dy dx?
2x?
Thank you.
Plus a big 0?
Right. And how about for, so if that's not right, we want dy dx to be 2x plus 3. How about D, y is equal to x squared plus 3x minus 2? dy dx is equal to 2x, whoa, 2x plus 3. And then here on this one, dy dx is equal to 4x plus 3. So that's not what we're looking for. Okay, we're looking for that one. So on 3, the answer was D.
And thanks to our technology glitches, you're at 15 minutes, just to give you a heads up.
Okay. Oh, so, okay, interesting. All right, let's try one more that I lead you through, hopefully not getting cut out. Then I'm going to give you guys one to do. All right, so 7.2, verifying solutions for differential equations, all examples from AP Classroom, just like before. This one for number 4 says, for what value of k, if any, will y equal k sine of 5x plus 2 cosine of 4x be a solution to the differential equation y double prime plus 16y equals negative 27 sine of 5x. This one's kind of interesting because now we're looking for this k value right here that's in our equation. And so strategically, what I would do here is I honestly wouldn't even look at my answers. They're not gonna, well, I guess you could maybe work backwards from the answers. I would probably just go ahead and take the derivative twice here so that I could then substitute in the second derivative into this equation and then kind of collect everything together and hope that everything kind of boils down to k equals some number. That's going to be my strategy. Anything to add, Mark, before I start going?
Nope, that's okay. Mine.
That's
just with color.
Okay. So here's my equation that I'm going to take the derivative of. Lots of good chain rule going on here as well. So y is equal to k sine 5x. I do not need to use product rule here because k is just a constant. It's a number like 7 or pi or something like that. So it's k and then times the derivative of sine x, which is cosine x. But in this case, it's cosine of 5x because the argument is 5x. And then times the derivative of that 5x, which is 5. And then plus derivative of 2 cosine 4x. Well, derivative of cosine is going to be the opposite of sine. So it's actually going to be minus, I'm going to say minus 2 sine of 4x. And then times the derivative of that 4x, which is 4. I'm just going to clean that up a little bit before I go forward and get the second derivative. So y prime is equal to 5k cosine of 5x, and then minus 8 sine of 4x. Second derivative, kind of similar in ways to the first.
And I was going to say, just while you're doing that, it seems cumbersome because there's 2 lines there for the first derivative, but as we get into review and we prep up this next month for the end of the course, those 4 times 2s can occur in your head you get pretty savvy with it.
Oh, absolutely. Like I probably would have said -8 right here if I wasn't kind of talking to.
Oh, and I'm sure most of our students would soon. I just want them to know that that's where you head, is these do become quicker.
Yeah, definitely. All right, 5K is still a coefficient here, no need for product rule. And the derivative of cosine is the opposite of sine. So in fact, let's go ahead and let's see if I can do what Mark said live. So I know that I'm gonna have to take the derivative of 5x, which is 5. So this turns into negative 25k sine of 5x. And then here, derivative of this sine function is going to be cosine. Because I have the 4x right here, I have to take the derivative of 4x, which is 4. So this is going to be minus 32. 4 times 8 is 32 cosine of 4x. So in this differential equation here, y double prime plus 16y is equal to negative 27 sine of 5x. I'm going to substitute this y double prime in, and hopefully a lot of things will add to 0, cancel out, whatever you want to call it. So let's see here. We have negative 25k sine of 5x minus 32 cosine of 4x. That's my y double prime. And then plus 16y, here's my y. So 16 times k sine 5x plus 2 cosine 4x. There, close off those parentheses. And then equals, negative 27 sine of 5x. So negative 25k sine of 5x minus 32 cosine of 4x, and then plus 16k sine of 5x, and then plus 32 cosine of 4x. I'm distributing there, doop, doop, like that, and then equals negative 27 sine of 5x. True confessions, like when I was doing this problem, I was making sure stuff was kind of canceling as I was going. So those two add to 0. These two add to whatever negative 25 plus 16 is. So I believe that's negative 9. So negative 9k sine of 5x, those are like terms, equals negative 27 sine of 5x. So structurally, these two are kind of in the same position. I can think about dividing both sides by sine of 5x or something like that. But really, as long as k is equal to negative 3, then this is a true statement. So if k is equal to 3.
To 3, yes.
Yeah, I said negative 3, but I meant, that brings up a thought of mine. If a teacher ever says, I was seeing if you were paying attention, they're lying. They're not. They're making mistakes all over the place. Okay, so this is definitely correct, though. Negative 9k equals negative 27, so k is equal to 3. Anything else, Mark?
No.
Okay.
I was working alongside you, and I got the same thing, but that happened yesterday, too. So.
Yeah, right. All right, this is one that I want you folks to try out there, please. And I'll read it out loud. It's very similar to the one I just worked. For what value of k, if any, will y e to the, for what value of k, if any, will y equals k e to the negative 2x plus 4 cosine of 3x be a solution to the differential equation y double prime plus 9y equals 26e to the negative 2x. I'm going to give you about a minute for that.
So what are you doing during this minute?
I'm picking papers up off the floor right now.
Fair enough.
Actually, Mark, if you want to grab my screen when you're done, are you working it?
I am working it.
Okay.
Yes.
Because that way I don't have to write it all out. Slow hand.
All right. You want me to grab it?
Yeah.
Okay. Easier said than done sometimes. There we go.
All right. Yep. I think one thing that's really nice that I see in Mark's work there is very organized. He's got his first derivative, his second derivative, and then he's checking. I love that question mark again, checking to see which one is a solution. And then he's substituting in for his y double prime and for his y, distributing and getting k is equal to 2.
Yeah, this one I actually didn't do a question mark. I put the question mark here, I guess. I didn't put it over the equal sign, but.
Yeah.
And I didn't write, just spacing wise, I saw I was going to get the positive 36 there. So that's why I didn't write that. I just knew those were going to cancel.
Yes. Yes. Again, yeah, I kind of mentioned that before, like you're kind of always looking ahead in the problem to see what cancels.
And the only reason I labeled these as given is because we were trying to give you guys time to go ahead and work this yourself. This is what I'd written first, and I'd left myself this space. So.
Oh, very nice. Because you knew you.
On a real test, I wouldn't do that because this is printed up there, but.
True.
Flipping screens or going off paper, another source sometimes.
True, true. Okay, so we're going to go ahead and give you another one to do. Actually, yeah, we're going to go ahead and give you guys another one to do. If I can find it from where it fell. Yeah, here it is. Okay, perfect. I'm going to grab
I'm sure we can go over because of the glitch. We have a little time there, but we are closing in on 3 minutes.
Okay. Well, this is the one that I wanted to have you guys try as well. And it says, it's number 5, of the following, which are solutions to the differential equation y double prime minus 10y prime plus 9y equals 0. And again, as you get more and more experience with this, you kind of look at certain options and say, that's not going to work, you know, like it's just going to not cancel out or whatever, depending on the nature of the equation that you're being presented with. So for example, I might go ahead and start messing around with this y equals 2 sine of 3x first, but I'm actually really curious about this exponential function. And here's why. I'm looking at this exponential function 5e to the x, and I can take the derivative of that in my head and hold it there. And I can also take the second derivative in my head and hold it there as well. And I can then verify pretty quickly by plugging those in and seeing what's going on. So and I know I'm skipping to Roman numeral 2, but for Roman numeral 2, if y is equal to 5e to the x, then y prime, no product rule needed, is equal to 5e to the x, and y double prime is equal to 5e to the x. So what happens when I substitute into this equation here? If I'm checking it, I have y double prime, which is 5e to the x, minus 10 times my y prime, which is 5e to the x, and then plus my 9y, which was 5e to the x. We're checking to see, does this equal 0? 5 minus 50 plus 45, does that end up equaling 0? Yes, it does. So definitely 2 is a possibility. So just in terms of, and many of you are very savvy test takers, I mean, just in terms of that information alone, I can just go straight to knowing that B and D would be my options. Well, if 2 is a possibility, I'm pretty suspicious that Roman numeral 3 would be a possibility as well. And I could go ahead and check that too.
If you want to fast forward, Verge, I can put that up there for you.
Yeah, go ahead and put it up there for us. Let's see what happens.
So you can see where I did exactly what you were saying, where I did these in my head. And so it tested those and I saw 2 worked. So we're looking at B or D. So again, this can be a thought bubble or just work off to the side, but chain rule here. So we're going to have our first derivative is 9c e to the 9x. And then our second derivative, an additional 9 is going to come out here and multiply and get 81c e to the 9x. And we're throwing that back into our differential equation. So my second derivative minus 10 times my first plus 9 times my original, which I think oops, yep, that's not good. We need a 9 there. And we can see that we have the 81 plus 9 and then minus 90 for our coefficients. So this one works.
So it's Roman numeral 2 and Roman numeral 3.
So it's choice D.
Yep, choice D. Okay. So I think we need to wrap it up because that went very, very fast for me anyway, because I lost my connectivity completely. But I think Mark is going to bring us back to the PowerPoint. Am I right about that, Mark? Yep. Okay, so we can kind of do a little bit of wrap up. I had some teachers who were asking me what kind of homework should we be assigning? And, you know, it's going to be different for different teachers, different schools, different students, but you suggested practice would be to go to the packet that's going to be in the Dropbox very shortly and do some more of them. There's one that is particularly challenging. And if you're a BC student watching some of these AB videos, you might want to try that really challenging one. It's number 2. And we didn't have time for that one today, but an AB student can try that one as well.
I believe I was going to say, I believe the 5 we didn't use were 3, 5, 6, 8, and 9.
Okay. So those would be great suggested practice. You can check your answers, and we're going to lead off tomorrow's lesson or the next time you watch this live, we're going to lead off with working one of those that we did not work today. Okay. We hope that you join us the next time, and to get our information, either use that QR code or use that bit.ly link that'll take you to the PDFs. And this is a new slide here. This is very important for students to read and for teachers to share with your students. College Board is working very, very hard to provide device and internet access to students who do not have device or internet access. So if you are one of those students, or if you know of a student in that situation, or if you're a teacher who can share this information widely, you need to contact College Board directly at that cb.org and then /tech, TEC8.
And I clicked through it earlier today. It's a survey. You say who you are, and then you also include in there whether you're the person that needs the tech or not. So this is not, because the initial thought is, well, if I don't have the tech, how am I seeing this slide? Well, if you know of people, please.
That's an excellent
help
point.
them out.
Yeah. And if you could forward it to your AP coordinator as well, and they might know certain kids who they could fill out the information for.
I will also put a link. I'll put that link in the Dropbox, as well as a link to the CET, the course and exam description that we mentioned earlier in the video.
Oh, thank you, Mark. Okay, thanks for watching us. Thank you for your patience. We're doing the best that we can, and we'll bring you more tomorrow. Tomorrow is 7.3 Slopefield.
And then it's Friday weekend.